Hello and welcome guys to Get Alert channel. Today we are going to discuss about attribute closure. First, what is attribute closure? For example, we take a table and it has many attributes, and with any one of the attribute we can able to get all the possible attributes. Then that attribute closure is said to be the attribute closure. For example, we take the two examples here. One is a relation R, Q, R, S, T, U is the attributes of it. Relation R, X, Y, Z, A, B are the attributes of it. First, we need to do the Q closure. First of all, what is the definition of closure here? Set of all possible attributes that can be generated by X is called the attribute closure of X. In the same way, we try for the Q here. With Q, what are the attributes possible we can get from Q? We can get Q. Q functional dependency R is there, so R is dependent on Q, so we need to include R here. From R we can get T, so include T here. From T we can get S, include S here. From S you can get U, include here. From U we can get something else here. No, we can't get anything. It is closer up till here now. Now in the same way we can do R closure. What is R closure here? Observe very carefully. We can get R from R closure. From R we can get T. From T we can get S. From S we can get U. We can't get Q because something should be there on left side. It should derive Q, but it's not there. So this is the answer up till now. We do the T closure. What could be the T closure now? We should write T. From T we can derive S. We are writing S. From S we can derive U. From U we can derive something else. From T we derived S. From S we derived U. We can't derive anything. So that's all. It's completed. Now let us do U. I'm writing U closure here. What can we get from U closure? Nothing is there, simply U. Now in the same way, do the S closure. From S closure we can get S and we can get U. In this way we need to do closure. Now take this table, we have not do for this also. Now this is another question similar to the same concept. Now this is the question you can see here. Now first let us do the X closure. What can we get from X closure? Simply X. Now let us do the Y closure. What can we get from Y closure here? Simply Y. Now we can do the Z closure. With Z closure we can get Z, and with Z we can derive A na, so we need to write A here. With A we can derive B, so B should be included here anyhow. With B we can't derive anything else, so this is the answer. Now A closure. With A what can we derive? We can derive A as well as B. Can we derive something else from here? No, nothing can be derived here. Now we need to do B closure now. What can we get from B closure? First B need to be there. With B anything else can be derived? No, nothing can be derived. So that's all. Now you need to think some logically. What should be the XY closure? In XY closure, observe very carefully. this is the xy attribute. It is not x, it's not y. So while doing the xy closure attribute, you should include x as well as y, and the attributes which can be derived from x also should be included, y also should be included. Now xy will derive a will derive b. Now does x derive something else? No. Y derive something else? Nothing is there. Now if you look at carefully here, ay derives z. We have ay here, so it also can derive z now. You write z here. From z we can derive a. We have yz here. With yz we can derive xb. Xb is also there here. I think we got all the attributes now. So it is like this. This is a xy attribute closure. Now similarly you do the yz attribute closure now. In yz attribute closure, y should be included, z should be included, the attributes which can be derived from yz also should be included. You see, yz derives xb, xb are included. Now xy is there, xy will derive a from this, so that should be included here. Xy is there, it is deriving a. Now a is deriving b, it is there. I think we got all things here, x, y, z, a, b. So it is completed now. Now x, y, y, z, z, a. Let us do a, z closure. What can we get from a, z closure? There is a attribute here, so it should be there. There is z attribute, so it should be included. Now a, z closure. With a we can derive b. You see, there is a in the closure already. With a we can derive b, so b should be there here. With z we can derive something else. With z we can derive a, that's a cyclic thing, not required. Now a, y can derive z, not required. X, y can derive a, but x, y are not there. So I think it is closed up till now. That closure is like this. These are very important concepts. These are repeated questions asked in GATE exam. I am taking one more example. Zx, Az. Let us do Ax closure. Remaining you should try. In Ax closure, what? Now Ax closure. In Ax closure, we should include A as well as X should be included. Now with A and X can be derived something else. With A we can derive B, so B should be included. With B we can derive something, no. With Ax, I think it's up here. We can't derive something else because X requires Y to derive something else. I think it is all, that's all. Now you have learned how to do 2 attribute closure. Now I will do 3 attribute closure. Remaining you should try. Remaining attribute closure. It is an exercise for you. Now I am doing X, Y, Z closure. This is a 3 attribute closure. Look very carefully. X, Y, Z are obvious should be there. With xy here we can derive a, so that a I am including in this closure. With yz we can derive xb. Yz is there, x is there, so b should be included, so I am writing b here. From a we can derive b, already is there. I think we got all attributes now. We can't derive something else because x, y, z, a, b are the total attributes. We got the total attributes from here. This is the closure. In this way you can do any number of attributes combination closure. And thank you for this lecture.